Greetings and welcome, friends. We're taking a look at completing the square, the homework from it, of course, page 351. Problem 19 here specifically said, what value of c would make this a perfect square trinomial? Well, to find our new c term, the little formula we had was b divided by 2 all squared. So in our case, I would do negative hundo divided by 2 and square it in parentheses, so that negative is going to become positive. So that's negative 50 squared. And I believe that's going to be 2500 is what would give that a perfect square trinomial. So that's all they were looking for there. I don't want you to solve nothing. It wasn't set equal to 0. Blah, blah, blah. 21. All right, here's the first for real problem. So the idea was, step 1, move the old c term to the other side. So that is not the number of ones that were in that. Add 18 to both sides. Here we go. Here we go. So x squared minus plus 3x blank equals 18 blank. Right? So let's find our new c term. So that's going to be 3 over 2 all squared, which is 9/4 when I square top and bottom. So don't go the the decimal route.
That's what I did when I screwed up.
Oh. So now what I would do is factor this left-hand side. Fast factor it. That's going to be what all squared? Well, it'll have an x, and it'll have a positive 3/2. Right. And on the right-hand side, I need a common denominator, which is 4, so multiply by 4 over 4. 18 times 4 is 72, plus 9 is 81 fourths. Aha. Next step, root, plus or minus, don't forget it, because it's all about technique. X plus 3/2 equals plus or minus, the square root of 81 is 9, the square root of 4 is 2, and now we'll subtract 3/2 from both sides. So hopefully we're all writing down corrections if we got this problem wrong. Right.
You know it.
That's what I like to hear. So let's see, negative 3 plus 9 is 6/2. And over here I'd have negative 3 minus 9 is negative 12/2. Let's simplify those. That's going to be 3 and negative 6. So those are my answers. The fact that these answers turned out to be rational numbers, meaning there's no radical in them, right? There's no crazy things. It's just a number that could be written as a fraction, means that this original problem was factorable. All right? So that's what that means. Actually, tell you what, for funsies, let's factor this super quick. Just for fun, just to compare the methods. So in this case, I would find the factors of 18, 1 and 18, 2 and 9. There's no GCF. 3 and 6. There's no pattern here either. And which of these subtract to be 3? Well, that'd be 3 and 6. And then I'd have x with a 3, x with a 6 equals 0. And in this case, it's actually going to be faster. So when they're factorable, it's nice to do it out that way, if we're allowed to, I suppose. Well, unless it specifically says, use completing the square. But I just want to point out that when a problem is factorable, sometimes that can be the faster way, unless you have to use the AC method or something. So what I want to point out, though, is that not all problems are factorable. So there we go, is the factorable version of that. But you didn't have to do that last night. I just wanted to point out, same answers, different approach.
I like that better.
Yeah. But we got to know all our techniques, because sometimes factoring is weak. Let's see. Last problem, 27. Subtract 11z's from both sides. So I'll have x squared plus 4x blank equals negative 11 blank. All right. So let's find our new c term. That's 4 over 2 all squared, which is equal to 4. And we'll plus 4 here, plus 4 there. And then we can fast factor this. Negative 11 plus 4 is going to be negative 7. Aww. Is the negative more influential there? Root, both sides. Plus or minus. Don't forget it. So I'll have x plus 2 equals plus or minus. Hey, the square root of negative 7. I could pull out a negative 1 from that. Am I right? And I'll solve for x subtracting 2. X is by itself. And I'll get x equals negative 2 plus or minus I square roots of 7, because the square root of negative 1 is I. So that means, graphically speaking, if I was to take my original problem and set it equal to y instead of 0, all right?
I don't think we're going to I come
Because the square root of a negative is imaginary. So let me graph this here real quick for us. X squared plus 4x plus 11. If I was to graph this, there we are. This is what the graph would look like. And notice that there are no x-intercepts, none, because it's opening upwards and its k-value was positive, so it's just never ever going to cross the x-axis, which is why the solutions of this are imaginary. Yeah. So that's the homework, friends. Thanks for hanging out. Bye-bye.